So I'm Jerry Frenkil from SI2, Vice Chair of 2416, and I hope you all noticed how Voin and I standardized on our outfits. You know, we're fully bought into this whole business of standardization. So we're taking it all the way. All right, so green, but okay, I'll get this. Okay, so you've seen this slide a couple times already. I'm not going to elaborate on it, but again, I just want to emphasize we put this together as a group. The intent is for all three standards to work together. This was focused on power. Voin and I extended that to our clothing. So in 2416, we have a number of different companies involved. This is pared down. Someone commented earlier about the issues of M&A, and yes, we had more involved, but these are the active ones at the moment. You can see we have a broad representation. So given that there are multiple standards, I think it's important for each one of us to talk about what are we trying to address. And you heard from 1801, you heard from 2415. So I want to talk a little bit about what 2416 is focusing on. So the earlier diagram showing the three standards kind of showed us at the bottom, and we are largely working bottom up, and we're focused on IP and component abstraction. In addition to that, we are looking at PVT independent modeling. I'll talk more about that. The term independent modeling, PVT independence is overloaded, so I want to explain that a bit. And we also want to make these models operable across the design flow from different points. Today, that's one of the holes that we have. There are power models for this phase. There are separate power models for that phase. Getting those the power models to be congruent in itself is a challenge. And we see that especially as we move between abstraction layers. So we'd like to have a model that an early architect can use, as well as a verification engineer. So why do we need to address each of these issues? To begin with, if we're going to do power-aware system simulations, we need models for that. Again, people do this today. They use models, but they're ad hoc, they're homegrown, accuracy is questionable, and congruence with the models used in the other parts of the design phase is questionable. But to make these efficient, to make the whole process efficient, the abstraction is essential. So we need not gate-level models to be used at the system level, but system-level power models to be used at the system level. As Voin showed you, the systems have a diverse set of components. Whether you're looking at a board, or a multi-board system, or just an SoC, the components within that SoC even are diverse. And we need to recognize that because the modeling requirements for the different types of components can be different. So that has led us to the point where we believe we need a formalized approach to the modeling so as to be able to consistently represent the power of these diverse set of components. Now regarding PVT, today if you get a timing model or a power model, they're characterized at a particular PVT point, often called a corner, although the term corner gets a little abused these days. This is an enormous burden for IP developers. It takes time, it takes a lot of compute resources, the models tend to become large, and then there's the question of, well, how many different PVT points do we need? And it's not uncommon for SoC teams to find that, they get into the design phase and they go, oh my gosh, I'd like to look at another PVT point, but they don't have that. It wasn't characterized in the standard fashion initially. It's either going to cost them more time or money to get those from the IP vendor, or they hack it, or they don't do it. It's not a good situation. And then finally, we want to do this so that we can reuse power models. As I just mentioned, getting these models at different PVT points or for different phases of your design is a big burden. However, if you can develop a power model that can be used at different points in time, then the overall cost and resources needed to create that the whole set of models goes down substantially. In addition, what we see is that designers, architects who begin new designs will often create a power model for their needs, but then they have to throw the data away because there's no way to move that data from the ad hoc model structure they used into another ad hoc structure or a formalized structure later on. So power model reuse is an important requirement, we believe. So this slide's a little busy, but this talks a little bit about how we intend to do this. Let me get a pointer. The first part is the basic data within a model would not be represented as power or energy. It would be represented by some other abstraction, whether it's a charging capacitance or leaking widths, transistor widths, or things like that. And the reason for that is that delays the binding of the PVT points to later in the overall process. And it makes it easier to achieve power model reuse. It makes it easier to get very quick early estimates. And so this is the basic approach that we're following in 2416. Now, we are aware that there are legacy power models that are PVT dependent. And so we need a mechanism to address that. We have that as part of our requirements. We have not yet worked that through, but we have recognized that that is going to be a requirement going forward. Further, in addition to the fundamental types of storage, we will have multiple interfaces into this storage. And that allows us to support different abstractions or even different standards. I'll talk about that a bit more in a moment. So, who will benefit from this standard? We identified two different groups of engineers who will benefit. We call them model producers or generators and model consumers. So the first group are basically those people who create models themselves. Primarily, this tends to be library development groups, IP development groups. They'll create models, they'll pass them on to implementers later on. However, there is a set of users, we call them architects and design explorers, who need to be able to create a model on their own and use it themselves. But basically, the concept of producers and consumers helps us understand the requirements. The consumers are more the traditional users of models that we tend to think about. These are the people who are actually creating the design themselves. They're integrating the IP or the chips. Now, where are we right now? We've been meeting regularly, roughly about twice a month. As I commented earlier, we've had a little bit of roster cleanup due to M&A, although the logo list I showed earlier is correct as of a couple days ago. We've had a number of presentations from members talking about their perspectives, their requirements, their experiences, and we've made very good progress on a requirements document. In particular, we've enumerated different use cases that I'll show again in just a moment. We've defined those, and actually the group has explicitly voted on these, so we have agreement across all members that these are the use cases we need to support. As I commented a moment ago, there are two major categories of the use cases: model generation, model consumption. Across those two groups, we identified 11 different use cases. And we also identified 4 different ways that these models, the 2416 models, might be used. With 2415 and 1801, possibly 2415 and 2416 directly, 2416 and 1801, and 2416 standalone. So I'm not going to go through all of this, but this is basically the spreadsheet from our spec of the model generation use cases. We see here There's the classic soft IP. It's listed as only because there's a slight variant where you have soft IP with some embedded hard IP that tends usually to be a memory, a compiled memory. Then there's hard IP all by itself. And then there's the case where for an EDA tool provider, they're actually creating software to generate the tool. So we've discussed all these possible variations, and we've denoted what we believe will be the primary use cases for each of the, or I should say the primary interactions for each of the use cases. Here's the model consumption. This one tends to be filled out pretty much across the board, but we do get, when we get to software, the use in software, we tend to see it specifically with 2415 in one fashion or another. So the next steps for us, we need to complete our requirements list. We've completed our analysis of the use cases, and now we are deriving the requirements from those use cases. We also need to define the specific interface requirements, both for 1801 and 2415. I mentioned a moment ago about we need a facility for handling PVT independent models with PVT dependent models. We have some ideas on that, but we haven't defined that yet. And we intend to call for contributions before year end. There are several member companies who have indicated they have technology that is copacetic with what we're talking about. So we will have discussions about formal contributions shortly. So to summarize, we feel like we've got very good participation from a diverse member set from both IP vendors, IP users, EDA vendors. There's also some cross-fertilization between members of 2415 participating in our meetings and 1801 and vice versa. So we're feeling quite good about that. We feel we've made good progress towards a spec. We've got the use models all defined and agreed upon, and we're deriving the requirements, the specific requirements from those use models. And our next steps are we'll complete the requirements document and call for contributions. That's all I've got to say. Thank you very much for your attention and participation today.
Any questions for Jerry?